Hello, welcome back. As we discussed in the previous video, in a mobile world, we need to decouple our usage of information systems from where their users are located. Thus, an information system might have many different users scattered over multiple locations, and each of them wants to be able to access the information system seamlessly from various places and devices. This is obviously a communication challenge. This challenge is met at two different levels that complement each other: a distributed infrastructure and potentially distributed information systems. We will discuss distributed information systems in this section, and we'll address distributed infrastructures in the next. To illustrate how these two levels of distribution operate, we will resort to a business world analogy: how companies can attain global reach for their products and services by combining global logistics with a potentially distributed business model or business architecture. In one end of the spectrum, a company may choose to concentrate all its operations in just one place or area, such as a Chinese manufacturer of TV sets or mobile telephones that decides to carry out all its activities there. Of course, in real life, it would still require some global sourcing of components. It could then supply customers throughout the world by selling its products over the internet and shipping them through a distributed global logistics system, say shipping them via UPS. The IS equivalent of this centralized company plus distributed logistics would be a centralized information system remotely accessed by its users through a distributed telecommunications infrastructure, such as internet and/or the company's own network. This approach, in its simplest form, has been used since over 50 years ago to remotely access monolithic information systems being run on powerful central computers traditionally called mainframes. In this simple model, all the software and data of an information system resides in a central computer. Users access it remotely through telecommunications, using what is sometimes referred to as dumb terminals, in the sense that they are merely access devices that do not carry out any of the application's logic. This fairly inefficient model has been gradually replaced by various types of distributed information systems. In distributed information systems, as opposed to monolithic, remotely accessed information systems, the application's software and/or data, and consequently the execution of the tasks that make up the information system's logic, is spread, distributed over various computers. In our business analogy, distributed systems would correspond with distributed companies. In the opposite end of the spectrum, a global computer manufacturer might have research and development centers in several continents, specialized manufacturing facilities spread around the world, and sales and service subsidiaries in each country that would directly interact with their customers. This highly distributed business architecture would also rely on a distributed global logistics infrastructure. However, in this case, these logistic activities would mainly support movements within the firm, between the various units, as opposed to between the firm and its users. In information systems, the two main distributed architectures are client-server and peer-to-peer. In peer-to-peer architecture, best known for its application to file sharing, such as audio or video sharing, each computer or node talks directly to each other as a peer. In this section, we will, however, basically focus on the client-server architecture, which is currently predominant in the MIS or Management Information Systems arena. As its name suggests, it differentiates between client nodes that request services or data and server nodes that provide these services or data. In its simplest form, a two-tier client-server information system would correspond, in our business analogy, to a company with one central factory where products are manufactured, the server, and various sales and service subsidiaries, the clients, located next to its major customers, the users. Customers would interact with the nearest subsidiary based on their needs. The subsidiary would then request the appropriate products to the factory. Once the subsidiary receives these products, it might combine or assemble them in their final form maybe complement them with some services such as on-site installation and thus fulfill the customer's needs. In a two-tier client-server information system, users would interact with a client module of the application, that is a subset of the software programs and data that make up the information system, typically running on a client computer, such as a PC or a mobile device. A user might, for example, start a mobile banking app, the client module, in her smartphone, the client node. This app is actually a set of programs and data that reside and are executed in the smartphone and carry out some activities such as providing a graphical user interface and presenting the user with options. Very soon, however, this client module will realize that it cannot fulfill the customer's needs, such as checking her current account balance with the programs and data it has. The client module will therefore issue a request for this data through the distributed telecommunications infrastructure to the server module, the central banking application. The server module is therefore the remaining subset of the software products and data that make up the information system and would typically run on a large central server. The server module would then send back to the client module the requested data through the distributed telecommunications infrastructure. The client module would then present this data to the users and continue the interaction until it is, again, unable to fulfill the customer's needs. For example, because she wants to transfer some money between two of her accounts. The client module would then send this request. This time it would be a request for a service, not just for data. The server module would execute it and confirm back to the client module, which in turn would confirm it to the user. This client-server architecture allows each task to be carried out wherever it is more efficient, client or server, and reduces the load on the telecommunications infrastructure. In subsequent videos, we shall extend the concept to multiple layers architectures and discuss other examples.